Okie dokie, so pause the video, give it a go yourself first. So the next question is about expert systems. So when we think about expert systems, think of like WebMD. So this is WebMD. I am 21 years old. I am a male. Continue. Let's click on my symptoms. I've got a head. Okay, baby soft spot. Yeah, well, bald. Yeah, I'm bald. Yeah. No, don't have a deformed head. I don't think. Early grey hair. I had a grey hair the other day. Oh, that was depressing. I don't know what baby soft spot is, so get rid of that. Hair dryness. Age losing hair. You could say pattern baldness. Okay, yeah, that's what okay. Okay, so I typed in my facts. I'm using this really nice interface. Yeah. Okay, I've got head lice. There you go. Problem solved. I'll sort myself out with head lice. Yeah, okay, so yeah. Well, an expert system needs a knowledge base. Knowledge base is basically, it needs rules and facts. The rules are made from the facts to make decisions. So on that video of WebMD, I typed in the facts about me, the boldness. From that, rules were created. From that, it told me I had wingworm. Whatever. Okay, so every expert system needs to have facts entered. Rules are then generated, that means created based on these facts. So it learns about all these different facts, it then puts into different rules. Rules are basically like different, in this WebMD, different diagnoses. So if I typed in a cold, well actually if I typed in I've got a runny nose, that is a fact. If I type in I've got a sore throat, that is a fact. A rule is now being created, or it's been created, it's learned, but if you've got a runny nose and sore throat, the likelihood is you've got a cold. I might tell the AI, if I'm training it, wrong, you also need to have a cold. You can have a runny nose without a sore throat to basically have a cold. So you only need one of these to have a cold. So it will learn, okay, in future, based on this fat runny nose, you've got a cold. Sore throat, you can have a cold. If you've got both, you can have a cold. Identify 3 other components that are present in an expert system. So we know that it needs to be rule-based. So the rule-based works with the knowledge base. The knowledge base is the facts. The rule base is the rules. You can bind them together. You then have the interface. So WebMD, have that picture of that human where I clicked on the head. I then click on the different problems I've got. So it was a nice interface for me to use. And the final thing is the inference engine. So the inference engine is basically what looks at all the different rules and says which one's most likely. So let's go through this and let me tidy this up a little bit. Okay. So I type in, I've got a runny nose. That's one fact. That says noise, it meant to say nose. I also type in, I've got a cough. Now you can appreciate it could be that I've got a fever, and I can have a cold, I can have COVID. So what it'll do, the inference engine, is it'll look at all these possible outcomes based on these two things. So if I've got a runny nose and I've got a cough, it could be a fever, it could be a cold, it could be a COVID. And it'll give a probability that I've got a fever. It's going to be low, it's going to be like 20%. This is going to be like 70% and 10%. And that's because there's no other real symptoms. If there's no real other symptoms, the likelihood is I've only got a simple cold. So the inference engine matches the facts against the rules to give a possible outcome and diagnose me with that. So an expert system needs rules, it needs an interface, it needs an inference engine, and it needs the facts, the knowledge base. Those are all components of an expert system. And remember, an expert system is a type of narrow AI. Pause the video, give this question a go yourself first. You know the drill. Okay, so let me bring this bad boy out. It's got supervised and unsupervised learning. Let's go for it. So first thing first, supervised learning uses labeled data. So I'm using this, I'm going to label it as apple, apple, apple. So it feeds into the model of the AI, and the AI will make a guess when it sees this picture. It'll say it is an apple. Unsupervised, you have fruit, but they're not labeled. What happens is the AI in its model doesn't know it's an apple, but it knows it's different to this fruit and it's different to this fruit, that they're all different. So it classifies them into groups. So unsupervised, no labels are used. So when we talk about supervised, it takes the data, which is labeled as input, so it's inputted in, and predicts an output. So it predicts what it is. I believe that this is an apple. I believe that this is an orange. I believe that this is a pear. I believe that this is a gorilla. It's also able to predict future outcomes. So let's say it's a weather and it sees that it's a cloudy day, and it's seen that it's been a cloudy day like this in the past, and it's seen that it's rained in the cloudy day. When it's got this cloud, it always rains. Every time someone takes a photo of the sky and it's that cloud, it says there's a likelihood that of 80% it's going to rain. So what else do we know? So we know that it predicts an output. It's able to predict future outcomes, and I'm going to add based on previous data. So it's trained on previous data to make predictions. So if we were to feed in this apple here, after we've fed in these apples in terms of training, based on previous experiences, it'll be able to know this is an apple. If we were to feed in a banana, if it's had no training in it, that's by the way my banana, it's not going to have a clue it's a banana. It'll just mess it up. So we feed in, it's got no previous experiences, so it's not going to be able to predict it's a banana. It needs training. So if we labeled this banana, it'll be able to know after some training that this is a banana. If we were then to give it several bananas, like in a bunch like that, hopefully, based on previous experience of being trained of one banana, it's able to say this is a bunch of bananas. Whilst unsupervised, it doesn't use any labels at all. There are no labels being used in the training. It looks for unknown patterns. So doesn't have these patterns to begin with of grouping them banana, I don't know what this is, like apricot maybe? Apple, we're going to call this apricot. Apple, but it has an unknown information, but is able to group it on the fly. It only needs the input data to work. Supervised needs the labels, this should be labeled, not annotation, needs the labels and the input data. In unsupervised, it just needs the picture, the input data, it doesn't need any labels. So there are your three things about unsupervised. No labels are used, it looks for unknown patterns, it only needs input data. Whilst supervised, it's label data, it takes in your inputs and the label, and it's able to make predictions and an output. It's also able to learn from previous experiences and to make predictions of the future, like future outcomes. Yes, supervised does have unsupervised built into it as well, because once you finish your training, you can start feeding it in the actual fruit itself for it to work. Because eventually we don't want to keep saying this is a banana, this is an apple. We can just give it an apple and it's able to say it's an apple without the labels. So you take it away. Okay, at GCSE, you don't need to know about deep learning, but you can still give this exercise a go. Pause the video, match these up. Okay, let's rock and roll. Let's start with supervised learning. Which one of these suits the description of supervised learning? Simulates the data processing capabilities of a human brain to make decisions. Not really what we're looking at in terms of supervised learning. Enables learning by mapping an input, so like an apple, to an output. I predict it is an apple, and seeing if they match. That's basically what this is saying in English. Interesting. I'm going to leave that there as a question mark. Enables information to errors produced by the neural network to be transmitted. I've never learned about neural networks at GCSE, so I'm going to cross that off. Enables learning in an interactive environment by trial and error, using its own experiences. I know that this isn't to do with supervised learning. We should know what this one is, where it talks about trial and error. Enables learning by allowing the users, by allowing processors to discover patterns. So I know it's not that one because I know what this is, because it looks at patterns which weren't previously detected. So supervised learning is this. Even though it doesn't mention anything about labels, it means mapping, matching an input, like an apple, to the result. I believe it's an apple, and does it match or doesn't match? So, in fact, I'm going to make this red. Let's do reinforcement learning. So if you think about reinforcement learning with our bot, the bot which was learning to walk, it first of all was doing the worm, if you remember. And that was like a tadpole or a sperm. After it learned how to do the worm, we got it to kind of skip, but it wasn't able to turn. So what happened every single time? It was trial and error. It tried something, it failed, or it tried something and it passed. It got a reward or a punishment. So that would be this. Trial and error, reinforcement learning. Unsupervised learning is all about finding unknown patterns. We don't use labeled data. All it cares about is an input. We feed it into the system, and the system will put it into a category, a classification. Oh, that belongs here. It doesn't know it's an apple, it just knows that it belongs there. There are apples, those are bananas, and these are pears, actually cherries. So it's able to classify things. Deep learning does use neural networks. For those of you doing A-level and watching this video, deep learning is all about neural networks, but it's got nothing to do with errors produced by the neural network. It's got nothing to do with that. What it does have to do is those neural networks act as a brain to make decisions. Okay, so pause the video, give this question a go. So inference engine, where does that come from? Remember, that comes from expert systems, even though it says in the question. Okay, so remember, we've got your facts. The inference engine stores rules. So it stores the rules. And what happens is, it links the facts to the rules and gives a probability. So that's 1 mark, that's 2 marks, and third mark for the, in fact, stores rules, and the extra mark would be for the inference engine to use. So there we go. It stores our rules so that our inference engine can use it, so it can match all the rules against the facts to look at the probability of which, in WebMD, which symptom versus which diagnosis. You know the drill, pause the video, give us a go, and then let's go through it. Okay, so let's see what you've done. What are the characteristics of AI? So let's go through the main ones. Collects data and stores rules. Ability, that's his ability by the way. Ability to reason. Ability to learn. So if we talk about ability to learn, this would be adapting, so that means like changing, like the robot does, what it does, learn from mistakes. It can change its rules. So AI can change the rules which is created, like WebMD. It can change data which has been inputted. Think now about what we talk about in terms of AI in itself, like machine learning, not ability to learn just in general. AI can make predictions such as supervised learning, so predictions, and AI can analyze or find patterns like unsupervised learning. So how will this program of a robot going for a puzzle work? Use AI. It uses machine learning. It will use reinforcement learning. Which is a type of machine learning. Collects data. So that's what it will do. The agent will collect data about where it has been. So if we were, so for example, this bot, which is the agent, the robot is the agent in this maze, its job is to complete the maze. It would experiment, it'll go in different directions, it'll collect data, so it'll know that going that way doesn't work, so it'll learn from those mistakes. So it'll collect data about where it's been, but it also collects data about obstacles or problems. It remembers, so it stores successful actions. That's how it grows. Stores unsuccessful actions. So it remembers that moving this way isn't going to work. It remembers moving this way isn't going to work, so it's going to try this way. It's got further, but it still hasn't worked. So next time, it's going to try that way, and then that is an obstacle, a problem, which will have to be collected and then stored. So it could be using rewards and punishments. It's iterative, that means it'll loop. over and over and over again to get better each time. I'm going to put gets better each time, learn from mistakes.